All right, let's tackle a really important puzzle for anyone running apps in Azure. How do you get your virtual machines to talk to the internet? I mean, safely, reliably, and especially when you start to scale up. It sounds so simple, right? But trust me, making the wrong choice here can lead to some massive headaches down the line. So let's break it all down and find the right way to do it. So this is the core question, isn't it? Your application, it needs to hit an external API. Maybe it needs to download an update or send out a notification. It has to have an outbound connection. The thing is, Azure gives you a bunch of ways to do this, and they are definitely not all created equal. Picking the right one is absolutely crucial if you're building a real production-grade application.
Okay, the one key concept we have to get our heads around is SNAT. It stands for Source Network Address Translation. In the simplest terms, it's the magic trick that masks the private IP address of your virtual machine with a public IP address. This is what lets a machine that's tucked away inside your private network talk to the outside world without the outside world being able to talk directly back to it.
A great way to picture this is to think of a big office building. It's got one main public phone number that everyone knows. That's your public IP. But inside, you've got hundreds of people, each with their own private phone extension. The receptionist? Well, that's your SNAT. It takes all the outbound calls from all those private extensions and makes it look like they're all coming from that one single public number.
So now that we know what SNAT is, let's look at how Azure actually does it. There are basically 5 main ways to get outbound connectivity, and we're going to rank them. We'll go from the absolute best practice all the way down to the ones you should pretty much never use in production. And here it is, the entire ranking right up front so you can see the whole picture. I want you to notice that big split between explicit methods, where you're in control, and the implicit ones, where Azure is just kind of making guesses for you. We're going to walk through each one of these, starting at the top. But the key takeaway here is that your choice has a direct impact on how well your app can scale and how reliable it's going to be. Okay, first up, the undisputed champion, Azure NAT Gateway. This thing is a fully managed, super resilient service that was built for this one specific job. It makes everything simpler, it gives you static public IPs you can hand out for allow listing, and this is the most important part, it's designed from the ground up to avoid the single biggest problem with SNAT, which is port exhaustion. Seriously, if you're building a real app, this is where you should start. All right, next we have our OK options. These are perfectly fine in the right situation. First, just sticking a public IP directly on a VM. It's simple, it's a one-to-one relationship, and that VM gets all the ports it could ever need. Great for a single instance, but it just doesn't scale. Then there's using a load balancer with explicit outbound rules. This is also a solid choice. It gives you complete control to say exactly how SNAT should work, letting you manually assign ports and tune performance. It's good, but it can get a little complicated as you grow.
And now, let's talk about the methods you really should avoid. First, default outbound access. It's insecure, it uses a public IP that can change on you at any time, and it is absolutely not for production, period. And just as bad is using a load balancer without setting up those outbound rules. It's trap. Yeah, it works by default, but you have zero control, and it puts you at a huge risk of the exact problem we're about to talk about.
So I've said this a couple of times now, SNAT port exhaustion. What in the world is it? Well, this is the hidden danger that can bring your app's ability to talk to the internet to a grinding, sudden halt. And it often shows up in really mysterious ways. It all starts with this number, 64,000. That's how many ports you have to work with for SNAT for each public IP address you're using. And I know, it sounds like a huge number, right? But this resource is finite, and believe me, you can burn through it way faster than you think. So what even is a SNAT port? Well, every single time your VM makes a connection to something on the internet, it grabs one of these temporary ports. This is what creates a unique return address, basically. It's a combination of IPs and ports that ensures when the data comes back from the internet, it gets routed to the exact right process on your VM that asked for it. And this is just a perfect way to think about it. Imagine you open 2 tabs in your browser to the exact same website. How does your computer know which data goes to which tab? It's because of unique source ports. SNAT ports do that exact same job for every single outbound connection your application makes. Without them, it's just chaos. So this is the million-dollar question. You've got this fixed pool of 64,000 ports. Your application is busy. It's making thousands of connections. What happens when every single one of those ports is already in use? It's that simple. Any new attempt to make an outbound connection will just fail. There's no waiting, there's no queue, it just drops. And this is so hard to troubleshoot because from your app's point of view, it just looks like the network suddenly went down for no reason.
So, what's really happening? Well, the root cause is pretty straightforward. You're trying to share that fixed pool of 64,000 ports among way too many virtual machines in your backend. As your app scales up and you add more VMs, the slice of the pie that each individual VM gets, it gets smaller and smaller.
Now, this table, wow. This table really spells out the danger of using that implicit default SNAT with a load balancer. I mean, look at this. When your backend pool is small, say under 50 VMs, each one gets 1,000 ports. Okay, that's pretty decent. But just watch what happens as you scale. Once you get over 800 instances, each VM gets a measly 32 ports. 32! A single busy web server could blow through that in a matter of seconds. And boom, you've got connection failures.
Okay, so that's the problem. It's a pretty scary one. So how do we fix it? How do we design our Azure setup to be scalable and resilient and to just completely avoid this port exhaustion trap? Let's map out the path forward.
Here is your action plan. It's 4 simple steps. Number 1, just prioritize NAT Gateway. It was literally built to solve this problem. Number 2, if you have to use a load balancer, always be explicit with outbound rules so you can control port allocation. 3, this one's on the application side. Reuse your connections. Connection polling is way more efficient than constantly opening and closing new ones. And finally, number 4, you gotta monitor your SNAT port usage. You can't fix a problem that you can't see coming.
And here's a pro tip, a more advanced strategy. Sometimes you can just sidestep the entire problem. If you're connecting from your VM to another Azure service, like Azure SQL or Blob Storage, you should be using Azure Private Link. What this does is it routes your traffic over Microsoft's own secure backbone network, not the public internet. And since the traffic never goes out, there's no need for SNAT, which means there's zero risk of port exhaustion.
And that really brings us to the final thought I want to leave you with. As your application grows, as it serves more and more users, the demand on its outbound connections is going to grow right along with it. Those default implicit methods that seemed fine when you were just building a prototype, they are going to fail you at scale. So, I want you to go take a look at your own architecture and really ask yourself, is my outbound strategy ready for what's next?